Hello everyone, my name is Shambhavi. Hope you all are doing well. So basically our today's topic of discussion is student state distribution. Now this is another topic which we are having in the statistics, right? Now in the previous topics for a long time we had actually discussed about the confidence interval, standard deviation, all those things we had just discussed, Z score, right? Now we're starting out with a new topic for now, and that is student state distribution. Right, now basically what is it actually? Let me firstly explain you. After that I would just take on to you basically that where it is used. After that we'll be just discussing about the formulas and the other things. Right, so let me start writing here. So I would just tell you that basically for what it is used. Right, so I would just write here students T, and I would just in short form I would just write distribution. Okay, I'm just writing it in short form. So students T distribution is any member of a family, is any member of a family of a family of continuous probability distributions of a family of continuous. So here I'm just writing continuous. Just let me come down here. Okay, of continuous probability, and I will just write here probability distributions of continuous probability distribution that arise when when basically we are calculating. Estimating means calculating, right? When estimating the mean of a normally distributed population of a normally distributed population, right? So this is actually what is the definition for student state distribution, right? Just let me quickly write here population as well, and now I would just revise the definition once again so that you can just have an idea of this, right? So basically here it is written that student state distribution is any member of a family of continuous probability distribution that arise when estimating the mean of a normally distributed population. So first thing that we can just say from here is that student state distribution, right? It is basically any member of a family of continuous probability distribution, right? And second condition that when basically what is the condition at which it arises? So the condition is that it arises when estimating the mean of a normally distribution population. Right, so this is the thing which we can just say about the student state distribution as a intro for it. Right, now second thing which I just want to tell you here that basically how just we like write that thing and how just we like know it. Right, so for that I would just take a new color here so that it is a little bit differentiable. Okay, so now basically here I start, and here I write if you basically. Now first thing is that if you draw a simple random sample, we all know that what is a random sample, right? So if you draw a simple random sample, right? For random samples we had already covered this thing in the previous video, right? So if we draw a simple random sample, let's say of size n, okay, I'm just taking at let's say of size n, I'm simply taking a small n a, okay. Now basically from a population, right? So the random sample is always drawn from a population. So I'm just writing that thing here. Let's say if you draw a simple random sample of size n from a population that has approximately, I'm just simply writing approx here, okay? Just treat it as approximately as well. That has approximately a normal distribution with the mean mu. We all know that basically we denote the mean with the mu, right? So here I would just write the correct spelling, distribution with mean mu. So I'm just writing it the even a denotation here which is basically important. So I would just write here mu, okay? And unknown population standard deviation, and that is basically denoted by the sigma, right? So here I've just write that thing also, and unknown. So for standard deviation, I'm simply writing here as ST, okay? No need to just write the full form because we're just learning this thing from the very starting, right? And unknown standard deviation, I'm just writing the denotation that is sigma, fine. And basically now if we just want to calculate the T score, okay? And basically if comma calculate the T score. Now, basically, some of you must be thinking now we have heard about the Z score. Now, what is this actual T score? So, just wait a while, just have a little bit patience. In this video only, I'm just going to tell you that actually what is T score also. Right, just wait for 2 to 3 minutes for that. So, calculate the T score, and with that, basically, I will just write out the formula here that T is equal to, so that is x bar minus mu and divided by, and here I would just write s divided by under root of n. Right, so here whatever I have just written, it is like clear to all of you that basically what are the terms that I have written here, right? So, so the formula is this, and basically now from here I would just put a comma and I would just even write that then if this is the formula, then the T score, okay, the T score which we are actually talking about, then the T score follow our students T distribution, okay, follow our students and dash, and here I would just write T, and distribution, for distribution I would simply write this here, okay. So that is basically this T score is follow students T distribution and with. Now, what is one condition here? That condition is that with n minus 1 degrees of freedom. Okay, with n minus 1 degrees of freedom. Now, for degrees of freedom also, I would just let you know that thing in a while. Okay, degrees of freedom. Now, firstly, let's discuss about that T score which I was talking in the starting. So, just that T score, okay, which I have just written here. So, T score has the same interpretation, okay, T score has the same interpretation as Z score, so from here what I can just say is that the T score and the Z score are actually same to each other, okay. Now basically there is no very much difference between them, right? So it is T score has the same interpretation as Z score, right? So this is the thing. Now second thing that comes here, okay, just let me again just go down from here so that I can just write next thing. Now, next thing that comes here is that basically what it measures. So it measures how far x bar is from its mean mu. Okay, it basically measures that basically how far is x bar is from its mean mu, right? And what about the number that I have mentioned, that was n minus 1. So for that I would just write here the number. Now what the number n minus 1 is called as, it is basically is called as degree of freedom, is called as degree of freedom, right? So this is basically what we have about the students T distribution. Now just let me quickly read it out and explain you each and everything. So basically if you draw a simple random sample of size n from a population that has approximately a normal distribution with mean mu and unknown standard deviation sigma, then calculate the T score. So this is the formula for the calculation of the T score, okay? Then the T score follows a student's T distribution with n minus 1 degrees of freedom. Right, now if we are given, as I mentioned, that what is the condition on which this works. So basically if I draw a simple random sample, okay, let's say size for that is n, basically from a population. Now then that will basically have approximately a normal distribution, right? And the mean would be mu, and basically it will have some unknown standard deviation. So from that if I just calculate out my T score, so T is equal to x bar minus mu upon s upon under root of n. Right, now then the T score which I have calculated will actually follow a student's T distribution, and that would be having n minus 1 degrees of freedom. Right, so this is the whole idea about what I have just written. After that I have told about that what is a T score. So T score has the same interpretation as Z score there, okay. After that basically what does it measure? So it measures how far x bar is from its mean mu, okay. And after that the number n minus 1 is called as the degree of freedom. Right, so these are the things which I have here for the student's T distribution. After that it has basically two important properties. right? So I've just write that two important properties here. So properties, I'm just talking about the students T score, okay? Sorry, students T distribution, not about the T score or anything else, okay? So just let me quickly put out the first property, and the first property is that the graph for the student, the graph for the students T distribution, distribution distribution is similar to the standard normal curve. Is standard, okay, just let me come down so that it's similar to the standard normal curve. Okay, so basically the graph which we plot with the help of a student's t distribution, okay, which we plot for it, it is basically similar to the standard normal curve, right, which we have basically here, okay. So this is the very first property for the student's t distribution, right. Now second property for the student's t distribution is that the mean the mean for the students, here I would just again write that same term students t. I will simply write this here, okay. Just one second, fine. Right, so the mean for the students t distribution is 0. Now basically if we're just going to calculate the mean for the students t distribution, so that will always be coming as 0 here, okay. And the distribution and the distribution is symmetric about 0, okay. And the basically distribution which we'll be making, that will be symmetric about, oh, that will be symmetric about 0, right. So these are the properties which we have for the student's t distribution. The first property is that the graph for the student's t distribution is similar to the standard normal curve, okay. And the second property is that the mean for the student's t distribution is 0 and the distribution is symmetric about 0, right. So basically, I hope you must have got a clear idea that actually what is the student state distribution, and basically what are the properties and what are other terms which we which we're having here, and what is the definition for this. Now after in the next videos, basically whenever we just see the examples for this, then it will be more clear to you that basically what we mean by student state distribution, and basically so how to solve out the questions for that, right. So this is all for this video. Till then, thank you and take care.